Okay, let's take a look at some reminders. And let me switch here. All right, so your lab number 3, don't forget you will be due for submission tomorrow at noon. Make sure you submit in time to claim your credits. And your lab number 4 is going to be a challenging lab, which is going to help you understand inheritance. We haven't really started inheritance officially just yet. I think we'll do that on Tuesday next week. So today we're going to finish off the last 2 topics about aggregation and composition. But I think for lab number 4, even though the theme will be inheritance, but releasing that early is also beneficial. A good part of it will still depend on your basics of OOP. So you can definitely get started once I release it tomorrow. And for your programming test 2, I know that your drop deadline is actually next Friday. I already reached out to the TA, but I'm not exactly sure if they can really prioritize the grading next week. But I'll try my best to really get the feedback and results, hopefully to make it available to you next Friday, I'm hoping. But if not, definitely Monday at the latest. I'll keep you posted about the process for grading. Any questions about the course? Anything you want me to clarify? So next week, Wednesday, there's no scheduled test. So what I plan to do is we can maybe get back to our regular demo in lab. So I'm going to be there next Wednesday. Maybe I can do a little bit coding demo on how you can program inheritance. That's going to also be helpful to your lab number 4. All right, so I'll send you a reminder again for next Wednesday, both labs. All right, let's now do some quick recap about what we said last time. So last time, basically 2 things we said. One is to finish off the equals method discussion. And especially we talk about this class over here called person collector, but try to see beyond this example. Any class that has an array attributes, you can definitely apply what we learned from this example. Especially your class does not necessarily contain only a single array. It might contain multiple arrays, and then the same principle is going to be applied when you define the equals method. Right? So when you study for this particular equals method, you want to pay more attention to phase number 4. Phase number 1 to phase number 3 will be very, very standard, so there should be no surprise. But for phase number 4, it really depends on what your particular application is asking for, so you want to pay more attention to it. And especially using the Boolean variable to control the entrance and exit of the loop. That's something we discussed very much earlier. And also you want to make sure whenever you got the equals method call, you want to figure out which version of the equals method is being called. Also, we talk about it. If you still got trouble, let me know. All right, sorry. Let me just go back. So that's about the equals method that we last discussed. And then we did quite a bit of tracing on Tuesday. So we got scenario number 1, number 2, number 3, number 4, right? So I don't need to repeat the details, okay? Just make sure you do the following at least. Josh, I'll get to you. Just give me one moment. Number 1, you want to make sure you kind of at least trace the code on paper. You know how to visualize them and how to figure out if the assertion should be pass or fail. That's most likely the question you're going to be receiving in the written test and exam. Even better will be if you try to load the code onto Eclipse, and then you can try to set a breakpoint on the beginning of the test case and try to trace them through line by line and see how the object structure change on the debugger. That'll be the most ideal exercise I'll recommend you do. Okay, I'll leave that to you. If you got any trouble completing these optional exercises, let me know. We can do maybe the beginning phase together, and then that will help you move on. Josh.
Shallow copy or deep copy?
Okay, good question. The question was, the equals method, does it really take into account shallow copy or deep copy? At the moment, when we talk about person collector, it's mainly about shallow copy, meaning that there was some sharing going on. But later today, I'm going to talk about the difference between shallow copy versus deep copy. We might only get to the details for deep copy maybe on Tuesday, the last part. But it's good to keep that in mind. So I would say whether it's going to be shallow copy or deep copy, don't be too concerned about the terminology. So all you got to do is check the test cases. What does it really require? Just program accordingly. That'll be enough. Okay. All right, any other questions before I move on? All right, so that's a part 1 that we spoke about on Tuesday. And then we spoke about call by value. The principle you always got to remember is if you got some method call here, and you got a corresponding method declaration or header over here. The way you connect these two is by call by value. Namely, there is some implicit assignment over here saying parameter is assigned to the arguments. Don't get the order wrong. The order here is important. Of course, depending on what the type it is for the parameter and arguments, it could be primitive versus reference. And you got to know the consequence of each. We spoke about 1, 2, 3, 4, 5. 5 examples on Tuesday. Right? Make sure you review them and understand the essence for each example. Right? They are not difficult here, so that's why when you grasp the basic about call by value, when I give you something that might be slightly more complicated, you will be able to handle them on the spot. That's really the expectation. Any question about call by value before we move on? Anyone? Anything you want me to clarify? Okay. Either it's clear or maybe you haven't studied yet, which you really have to do it soon. Written test number 2 is not next week, but it's coming at some point, right? All right, and we did a final connection between the equals method call, which is a method call, in which case call by value will still be applicable, right? We spoke about this one as well. You can also review it. That will just make the discussion complete about equals method. Alrighty, let's now talk about, question.
Just want to make sure. So when you're using, let's say, the dot equals method, the reason why we have to do typecasting is because when we're doing the call by value, we're making a new arrow that points to the argument, but then that arrow has that specific type and that. So that type could be really anything. It's just like maybe the reference, the static type might not match up with the dynamic type. Then we can't use it, but it still stores the address.
You're basically correct. Okay, how about, let me repeat. If you think about call by value for the equals method, the parameter is the object static type obj. And call by value tells you obj is going to copy the address of P3, meaning that obj and P3, they point to the same objects dynamically. However, the static type for obj is objects, meaning that it will restrict about the range of attributes or methods you can call on obj. In this case, only the ones in object class. So that's why if you don't really do the typecasting, if you simply say obj.x, obj.y, it's not going to compile. But we know that dynamically, obj is really pointing to point v2 objects. So that's why it will be safe to do the typecasting by creating another alias pointing to the same objects and then make that alias of the static type point v2, which is what we said earlier. Now, once you make that happen, you can use that alias, which is other, and call other.x, other.y.
I think you once mentioned like it could be really anything object to be, you're being very general. You can make it a person, you can make it an animal, you can make
Indeed,
it a furniture.
indeed.
So technically, if we make this very general, or we can make it very specific, we're just storing the address of it, but the static type determines what we could do with it, but it still stores the address.
That's correct. So let me leave this part maybe slightly for later. We'll definitely talk about it again. But you actually made the right observation. Given that the object here is a static type, you can see dynamically it might be pointing to some point v2, very generous. Or dynamically it might be pointing to, for example, point v1. Or it might be pointing to vaccine. Or it might be pointing to performance. It can be anything. But when you do the typecasting, you got to be more cautious. In this case, we pretty much know the dynamic type for obj. Given this particular check, we know that obj.getClass is the same as this.getClass, which tells us it's point v2. So we can safely cast this object here into point v2. However, when we talk about typecasting, maybe in about 2 weeks' time, there will be certain rules you have to follow. If you arbitrarily cast one thing to another, you might either get compilation error or you might get class cast exception. That's something we got to watch out for later. But for now, we are okay. That kind of answer your question, right? Good. Yes?
Would the equals method still work if we don't use the static object type?
Good. So the question was, what if we change the static type over here, for example, object, for example, into point v2? You may do that. You may do that. However, that one kind of violates the spirits of the equals method. Equals method is supposed to say, if I am point v2 objects, if I want to call the equals method, I want to compare with any objects, even if something that simply doesn't seem to be equal at all. But that's okay, I just return false. I should still allow the object to be taken for comparison. So you will sometimes see actually programmers actually try to make this static type rather than objects, but into something very specific. But this is something we'll see a little bit later. This can also cause other trouble, like a compilation error. But let's not worry about it. It will be too complicated to think of now. Yeah. All right, guys, any other questions? Yeah, keep thinking about the subject. It does take some time to digest, and it's normal to generate lots of confusion, lots of questions. That's why you need me to clarify, right? That's what I'm here for. Alrighty, let's now talk about some new stuff, which is not completely new, but interesting stuff. All right, I want to talk about aggregation and composition before I get to this part here. Let's now go over a little bit slides. All right, let's now define two things. So what is a container? Container object is simply an object that contains other objects. A little bit like a caller. Caller calls some other methods. Symmetrically, we got a type of object called containee, like a callee. A containee is basically contained within another object. Like a callee is called by another method, right? Similar. Hey, let's see an example right away. Let's say we have a course object, and we say a course has a faculty member as its instructor. What do I mean? Let's see here. Let's now assume this runtime structure over here. So you can see we got a course. Each course has its name called a title. For example, advanced OOP, like this course. And also has a professor, which points to another faculty object, which has a name, and then also has a list of teaching assignments. And in this case, I just make the array length 1. It could be length 2, length 3, length 4, etc. Similarly, you can see that the student object here has an ID, for example, Jim. Also got a list of courses the student is registered in. Also makes sense. And for now, I just make the array length 2. That can be arbitrarily long. Let's say we got these three types of object for discussion. And let's talk about the first scenario I talked about. I said each course has a faculty as its instructor. Okay? So for example, you can see for the course here, and one instructor, which is pointing to this object here. This course is also pointing to another faculty over here. So now we can say one is container, the other one is containee. So let's now do this one here. As far as these two links are concerned, this is a container. And these two are the containee. And just like a caller can be a callee at the same time, just in different context. Let's now see another example here on the slides. All right. And let's say each student is registered in a list of courses, right? So now we got another container-containee relationship. So now let me try to highlight another links over here. You can see for the students, and you can see we have some courses that's being taken, and we got another course that's being taken. So now in this case, student will be the container because it contains objects, right? All right, so for this one here, students over here, that will be the container. And for this, the same course type over here, that would be the containee. All right? Easy terminology, but I just got to master it. All right, let me now go back. And then there will be some properties for us to understand about containee. So number one, containees may be shared. That's about aliasing. So whenever we talk about sharing, it's really about aliasing. Okay, let me write it down. So whenever we talk about sharing, it's really to do with aliasing. That means the address of certain object is copied over in multiple places. Now, for example, if you take a look at this course object over here, and let me zoom in a little bit. The way to see if the course object is being shared is by seeing how many incoming errors we have in the diagram. You can see there is one here into the course. There's another one into the course. There is just another one into the course. Right? So that means it's being shared in 3 different places. You can try to modify the same objects using either this path, or this path. Right? That's aliasing that we spoke about earlier. And for this one specifically, I would like to maybe write it out. So you can also brush up a bit. Let's say for this course object specifically, so there are 3 ways to refer to it. Of course, the first way will be just EECS2030. That one is not as exciting. Let's talk about the other 2. One will be F1 dot TE at index 0. The other one will be here, S, which is Jin, CS at index 0, which also points to this course. All right? Let me now write it down. So for this course over here, I'll say star. Okay? So you got sharing. F1, the faculty dot TE, which is an array at index 0. And then also S, which will be the students dot CS, courses at index 0. Of course, if you try to compare these 2 by using equal, it's going to return to you true. Right? Nothing new. Just important to make sure you remember how to apply them. And whenever we got this equal, that means sharing. All right, any questions so far? All right. If that's good, let's now see another property. Another one is to say the containees may exist independently from their containers. What does that mean? If you look at the courses, for example, let's say for this course specifically, right now it's being shared by the faculty and also by the students. Let's say now we passed fall 2024. Let's say we move on to the winter. This particular course record might just be wiped out somehow for efficiency reason, for the space. But when we wipe out this course, do we also wipe out this instructor and the students? No, we don't. They still exist. They still have to continue with their journey. So that's why the shared objects, when they actually got discarded, it will be independent from the container over here. All right? So that's just some property. All right, so that's about so far we talk about sharing. There is another type of scenario that we have to consider called composition. Composition simply means the other extreme, no sharing. And let me just write it down first, and I'll give you a very quick demo. Whenever we talk about aggregation, it's really about sharing or aliasing. Right, that's scenario number 1. You can think about everything that we have been talking about up to now is about sharing. Okay? We allow sharing. On the other hand, when you talk about composition, it's really, I would say, very little or even no. That would be the basic idea for you to remember. So about sharing versus not sharing. All right, so today we're still going to do a little bit of aggregation just to just make sure you're okay. But I'm going to give you some a little bit more advanced example. And some basic example I will assign to you as exercises. And you can also find the answer in the slide. Okay, let me do a very quick demo about composition, just to illustrate that's something we have to implement as well in the slides. All right, so let's say this. Now imagine it, let me set this up. Okay, now there is a directory here. So the example I'm going to use will be directory and files. If you look at this one directory here called D1, if I open it, you can see I got 3 files. Let's say I got F1, now FA1. F1, there we go. We got 3 files inside. We got F1, F2, and F3. Okay. Now we say that the directory example should be an example of composition because let's say I want to make a copy of the directory. The way to do that, I'll keep D1 here, the original one. And then I'm just going to copy and paste. And this D12 is just a copy of it. If I open it, you can see that I got the exact structure under the directory. And we say that this will be composition because if, for example, I try to modify F1 over here and change that to be F4, is it going to impact the F1 over here, for example? It is not, right? It's obvious. So changing the containee in one container is not going to impact the containee in the other container. That's really the idea, composition. Right? We're going to see more detail about Java later. But I just want to give you some intuition right away. And there are some properties we can also talk about. So here, containee may be owned by a container. So we say each file is owned by its directory. If you change one, does it impact the other? And this one is also obvious. If you try to delete the directory, the container, it will delete all the containees at the same time. On the other hand, if you try to delete the students or delete the course, does it delete the student at the same time? No, it doesn't. So that's why aggregation and composition, they're different. All right, this slide here, very basic, just about terminology. Any questions about this? Anything that's already confusing to you, let me know. Yes? Yeah. That's correct. So when I talk about sharing, okay, there are several angles to see this. When I say sharing, the easiest way to think about it is there's no aliasing. If there's aliasing, that means it's sharing. But if you look at the diagram over here, you can see that when I have this course over here, the same course is being shared by this arrow over here, and also this arrow over here is being shared. So now, let's say, if I say I want to change the course name through this link, let's say the professor proposed to change the name of the course to say, rather than advanced OOP, just OOP. Would that be visible to the students who's also sharing this course? Yes, so this is sharing. That's what I meant. Composition would not allow this. That's something we'll see. And whether we should go for aggregation or composition, overall, it's a modeling decision you have to make. There's no right or wrong. You just have to say, given the particular problem I have, what JUnit test case is, I got to decide which one I'll go for. Okay. Okay, that's pretty good. And then let's now move on to talk about some modeling. Okay, this will be very useful knowledge for you to know. For this course, you are not required to know how to draw diagrams for modeling. However, you are required to know how to read them. I'll help you how to read them. You can see there is a diamond here. Whenever you see a diamond and it's empty, that means sharing, aggregation. Okay, empty diamond. It's sharing, aggregation. Oh, I just say aggregation. On the other hand, if you see another similar diamond but it's solid, like this. Okay, this will be sharing, but if you see it's solid. You'll see some example on the slide as well, but this one here will be composition. Okay, that's very easy to tell. And how do we interpret this diagram here? This is how you interpret it. I'll say it out first, and I'll write it down and show you the correspondence. The way to read this one here, there's a single aggregation. A course has, by aggregation, a single faculty member as their prof. Okay, I'm going to write it down. A course has, by aggregation, a single faculty as its prof. Okay, let's see the correspondence. This is one end, the course. This is the other end, faculty. I think okay, sorry, I spelled the faculty wrong. That could be confusing. Let me spell it again. There we go. Faculty here. And then when I say it's by aggregation, that's corresponding to this link over here. And then when I say a single is corresponding to this one over here. Typically, it's either one or star, but one means a single one. Finally, we have prof and prof. So a very simple question that I might ask would be, given the diagram, tell me its interpretation. That would be the correct answer. Or conversely, if I give you maybe the description there and choose the right diagram. Right? You see what I mean? All right, let's see another example here. This one here, the only difference is the star over here. Star here simply means 0 or more, or just multiple. 0 or more. And for this one, how do we interpret that? Okay, I'm going to state it out, and you can either write it down or maybe try to exercise, right? It's very simple, following the same pattern. A student has by aggregation 0 or more, or you say multiple, courses as their register courses. All right, that's the interpretation. Yeah, or if you cannot copy that down, just review the recording. You can just go to this part, and then you can see what I said. Just copy this pattern here. You just got to find the corresponding part accordingly. Now, what I talked about so far is the modeling. That's for diagram, for you to convey the ideas with others who may not know Java. But now you know Java. Given this modeling decision, either above or below, how do you turn that into Java code? That's something you already know. In the case where this is 1, you just have, for example, under course, you have a faculty reference type, prof. You can see the prof over here corresponding to prof of type faculty. Pretty straightforward. And what about the courses over here? In that way, you got student, you have the student class over here, and then it has the courses attributes of type course array. Right? And that's really the programming pattern we have been talking about since day 1. So you know how to do them. Now you just have to make sure you can link between modeling and the programming. All right, so this design, when I talk about, I'm really talking about modeling. And this part over here, implementation, of course, is programming. When you guys go to maybe 3311, software design, so you have to know how to draw this kind of design diagram before you ever get to the code level. But we don't really do that in this course. But I just want to give you some basics. All right, any question about aggregation? I'll go with you first.
So for the first example,
Yeah.
for Java implementation, you said it was like class course and faculty prof.
Mm-hmm.
So how would you know it's not the reverse?
Ah, okay. The reason is, it's just about how you interpret the aggregation link. So the way to do this is like this. When I say the course over here, because I know the diamond is pointing to here, it doesn't really point to both sides. That's how I know. So this one tells me the course contains an aggregation link of type faculty. So now the course contains an aggregation link, faculty. That's how I know. Similarly, you can see the students over here contains an aggregation link, but now this time the link is multiple, which is an array of courses. That's how I tell. So diamond is very important. But if I put diamond in both cases, of course you wouldn't be able to tell. But now there's only one side here. Okay. Question?
Instead of the star you have at 5, would that mean the array size is 5?
Ah, very good. Okay, it is possible. I would say that may not be so typical. Typically, you wouldn't really put any magic number here other than just 1. It is possible, of course, if you really want to make sure, I want to be very specific about the length of the array or the size of the aggregation, yes, you can put a 5. Yes, that's fine. Yeah, not typical. Usually, it's either a 1 or star. Of course, you wouldn't put 0. That doesn't make sense, right? Why would you put it in the first place? Okay, so that's about aggregation. And no more question. Good. Okay, and then let me now tell you what exercise you should really do. And then I'm going to move on to something a little bit trickier. That's something I'd like to spend time with you in the class. If you go back to the slides, you will see that this is something we spoke about. And I would say take this one here as the basic, right? So the exercise will be, number one, on slide number 13, there is one test case over here simply testing how objects in that particular example work. So this is something very familiar to you. That's something we have been doing since the beginning of the course, just tracing. This one, I'm pretty sure you can do it. I'll leave that to you. Exercise number one. And you can definitely see the solution already on the slides because everything should pass. And then we got exercise number two. Exercise number two will be this test number two. That's also a sequence of code, sequence of lines of code, and you can also trace them. I'll leave the choice to you. If you want to trace them on debugger, that'll be the most ideal. Or if you want to trace them just on a piece of paper to convince yourself, that's fine too. But you gotta make sure you do the exercise. I'll leave that part to you. Okay, and then now, before I get to more about this little bit more complicated scenario, I'd like to do one foundation knowledge background for you, which is a little bit tricky. That's why I want to talk about it first. Let me set it up. Just give me one moment. Okay, done. The example itself is a little bit contrived, like a symbolic, but I think that may be the best way to illustrate what's going on. Okay? You don't have to worry about this principal box just yet, or this here, not yet. Can we take a look at class B and class A? All right, so this is set up. In class A, we have private attributes. The first private attribute, OB, is of type B, which is referred to this class. The second private attribute is AI, integer type. Symmetrically, we also got B here. And then we got some private attributes, OA, of type A, which will give us this context over here. And also we got BI of type integer. We got two sets of private attributes. For private attributes, I'm going to box them in red. And also box them in red over here. And for private attributes, for each one of them, we're going to get public accessor to return the value. You can see here, we got here. Two of them. These two are the public accessor for OB and AI, respectively. For example, you can see get B is going to return OB. So that's why the return type is B. Get AI is going to return AI. That's why its return type is integer. Right? Straightforward. And similarly, we also got the two public methods in class B, which is going to return A and also BI. That's the setup. Pretty simple. But now the challenge for us is we have a series of trials over here, expression. And what we need to know is which ones will compile and which ones will not compile. Okay? This will be the deal. I will try to do the most tricky two with you. For the rest, exercise. And how would you do the exercise? Once you understand the principle, which I'm going to explain by using those two lines that are most difficult to understand, the rest will be you want to put class A and class B verbatim into Eclipse. And then let the compiler of Eclipse tell you whether each line should compile or not. And then if it says it compiles, convince yourself why. And if it does not compile, convince yourself why not, according to the principle. That'll be the exercise. But before that, let's be fair, I gotta teach you how to judge. All right, let's now do that. We're gonna look at this line here and this line here. Okay? Why don't I let you guys stare at these two lines for just 1 minute, so that'll be easier for you to follow. So I want you to look at this line here and also this line over here. Can you already tell whether these two lines should really compile or not? Okay, 1 minute. Tricky, but once we know about the principle, it's not too bad. There will be some subtle point you have to remember, which I'm going to show to you. All right? Just for you to, easier for you to understand, why don't we say this one here is number 1. Okay? This one over here is number 2. Okay? Okay, 20 more seconds. At least try to picture in your mind what number 1 is trying to do and what number 2 is trying to do. Before I take any inputs from you guys, if you have any, before that, let me share something here. The way to understand the intention, sometimes the intention may be compilable. Sometimes the intention may not be compilable. Okay? The intention is, this is referring to class A, the current context class. So this .ob refers to the OB here, which is of type B. That tells you this .ob is telling you to switch the context into class B. That's important. And then this .ob.bi is accessing some declared attribute bi. Seems to be okay. Seems to be a good intention. Okay, number 1. Number 2, this .ob, again, is going to give me B. So I switch the context to B. And then I get to get A. Get A is declared. It's going to return back to me A. I switch back to the context of A. And then, is there AI in A? Indeed, AI. Intentions of these 2 lines seem to be pretty clear and legitimate. Seem to be. Do they both compile? All right, that's a question. Anyone want to share thoughts? It's okay to be wrong. Anyone would like to try? Why don't you try first? Yes. You had a question first. Okay, go ahead. Number 1, the intention. Okay. It's good. This over here is referring to the current class A. Okay with it? Okay. When you say this.ob, it is to say now within A, I want to find OB, the attributes. OB is declared to be type B. So now that means this.ob is going to give me the type B. In order to continue to analyze, I need to switch the context to B. I want to see whether or not the BI here is declared under the B. Indeed, it is. That's important. I'm glad you asked. Good. You do similar reasoning. Doesn't matter how long the dot notation is. Just keep doing it. Okay, okay, number 1. Should number 1 compile? No? How about number 2? You guys are pretty smart. You see the color hint, right? So pink here means no. Green here means yes. But I'm not sure if you noticed that. But that's actually for me to remind. Okay, okay, that's pretty right. Let's now see why number 1 wouldn't compile. This is important. This will come with the principle. This is how you see it. So let me write it down. For number 1, we have this dot ob dot bi. Whenever you have the mix of access to private attributes, I would suggest first highlight the attribute that's private. In this case, we got OB over here, that's private. We got BI over here, that's also private. Okay, so we're going to justify individually, they are both legitimate, compilable. This one here, this.ob, is definitely fine because this is referring to A. You're just referring to some attributes within the same class. So that one's fine, not a problem. Okay. Usually the first part is not an issue, but let's now write it down. So this OB over here is actually good because OB is declared in class A. And this is referring to A. So this part is fine. All right? And since it is fine, you can see this part over here is going to give us the type B. This is important. And now we say that this.ob is the context objects, or context path, if you like. This.ob is the context path for this attribute bi. And the context path we're talking about has the type b, which we just figure out. Now, are we allowed to really access bi over here, which is a private attribute in b? Whether or not we should allow it depends on where are we writing this line. You can see we are writing this line over here in the context of class A. A here does not match the B. What does that mean? That means inside class A, you're not really allowed to see any private attributes in some outside class B. That's what it means, all right? So now, we want to say this line here has the context of A. Simply means we are writing this line in the context of A. And then the B here is we're trying to access the private attributes bi of B. Now we cannot do it in a different context class. So they don't match. So it doesn't compile. And let me do another example right away to see why the other one is okay. So this one, no, they don't match. The other one is slightly longer, but that's not too bad. Let's look at the other one. If I say this dot ob dot get a and then dot ai, slightly longer, okay? Our only concern is the private attributes. Whenever we're calling something that's public, there's no such concern. So the only thing that's private is ob here. Again, ob is private. And also ai over here is also private. Oh, let me highlight a little bit better. ai over here is also private. All right? As we said earlier, this part over here, this .ob is okay. And that one has the type A. Oh, sorry, beg your pardon. That one has the type B. Because this .ob is going to return B. And then what if we say B dot get A? Get A is going to return us something that's of type A. And this one is no conflict because it's public. No concern for anything that's public. So we are good to go until this point over here. Up to this point over here, when we say B dot get A, it's going to return something of type A. This is not important. We have this AI over here that's private. And we are trying to access some attribute AI that's private in class A, inside the context of this line of A. Now you can see the A here and the A here match. That's why it compiles. So there are two things you want to notice. Number one, for the private attributes in the dot notation, first of all, figure out the type for the context path, number one. Number two, figure out the line where you're writing this line, which is figure out the class where you're writing this line, which would be another class, and compare these two classes. In example number one, A and B do not match, so that's why it doesn't compile. In example number two, A and A match, so that's why it compiles. Oh, I'm going to write it down, and I'll take question. And this one over here, it will be good because A here and A here, they match. A here and A here, they match. So if you read through the principle now, it will make more sense. I'll leave the reading to you, but that's exactly the principle I illustrated to you. Another way to think about it is, whenever you got any line, this line here is in the context of X, and you're trying to access to some private attributes, let's say this name. What you got to figure out is, what's the type for this particular expression context path? Let's say that's of type X. If this X matches this X over here, compiles. If you got Y over here as the type, X and Y do not match, doesn't compile. All right, that's the summary of the principle. X will be okay, but if you got Y, it's not okay. Of course, you will need exercise. All right, the exercise I suggest, as I said in the very beginning, try to type out A and B into Eclipse, and then try to understand for every line over here whether it should compile or not. Eclipse will definitely tell you the correct answer, but you want to convince yourself whether that's really true by applying the principle we just explained over here. That's an important exercise for you to complete. All right, so any question about figuring out for 1 and 2? Anything you want me to repeat? Josh?
So the complexity is only when you're trying to ask private, but when you're going for accessors to get something, you don't have the other issue. The context object becomes another class of the same class.
Exactly. So the intuition, let's not lose the intuition. I think what Josh said here is pretty intuitive. The reason that this guy here should not compile is because this part over here is telling you it's of type class B. So when you try to access the BI of B that's private from another class A, that should not be allowed. You should not see anything that's private outside your own class. On the other hand, this one here, up to here is of class A. Is A allowed to see the private attribute of itself? Yes. That's the intuition. Yes. And the reason I'm talking about this is because when I talk about a more advanced example of aggregation, which we're going to do together, you will need a little bit of knowledge from here. Right? That's why I want to set up the context first. Take some time. Right? All right, any other clarification I can have for you? Good. All right, let's now move on. So the next set of exercises will be, let me help you a bit before, let's see some diagram. Oh, when you are given this diagram over here, you can see we got 3 instances of aggregation. We got instance number 1, 1 diamond, instance number 2, and also instance number 3. But for individual aggregation, we talk about how you can you can interpret them, right? You can refer to the notes from earlier. And this will be the runtime structure that we're gonna focus on. Okay, that's something we also said in the beginning, but I'm gonna remind you as we go for the exercise. So now we got 3 exercises. We'll see how much we can do. The rest can be like an exercise for you. The idea would be we want to have, let's say we got student class, we got course class, and we got faculty class. We're gonna consider if we are trying to implement some methods in the context of student class, how should we write the dot notation? Here, here, and here. Number 2, if we switch the context to another class, course, if we try to implement methods, this, and this, how should we write the dot notation instead? And also, if we switch the context to another class, faculty, how should we write the methods? The dot notation that works in one context class generally does not work in another class. So when you switch the context, you got to adapt. That's the main point. But we're going to do exercises to give you the feel. Okay, how about for the very first example, let me do that completely with you. And maybe we should let you have some interaction. So if you can share your thoughts, that'd be great. We'll see. Let's see the first one. We are having the student class over here. You can talk about Jin, student objects. You can always use the runtime example to help you decide how you can generalize them into method implementation. So now in the student class, we have first method, get ID. How can I get an ID for the students? That one is easy. You just want to return the ID for that particular student. Right? Let me ignore the omit the return keyword just for now. Okay? So this one here would be this dot ID. Oh, there's another assumption we are making. I just want to show you that on the slides. We are making the assumption, so we got private attributes, example, ID is private. We got correspondingly get ID as the public accessor, right, for every private attributes, just to let you know. Okay, let's now take a look. So this one here, you can say this dot ID, and also you can say this dot get ID. That one also works, either one. And this one here, I want to get a title of the course. But we're taking one parameter. What does that mean? Let's say if I write Jim.get title 0. What does that mean when I call this method? Number one, you can see that Jim here is of type students. Oh, I shouldn't say Jim. It should be S, right? Let me be precise. So if I say S dot get title 0, all right? This is the line to consider. If I say S is a students, and I say get title 0, that means go to the courses array, go to index 0, and return back to me the course. That will be the 0th course, or the first course taken by the students. Now, how do I implement this method in general? I should really return this dot CS, and then at index I. Right? Alternatively, I can also say, this is one way to do it. I can also say this dot get courses, the public accessor, and then just return and get index I. This is the alternative that will also work. Yes?
You want to return a string though, rather than...
Yeah, I agree. Thank you so much. Thank you for catching it. Indeed. Because here I got string over here, so that means I should go one more level. So once I get to the course, I can say title. So either I can say dot title, however, or I can say get title. Intention is good. Either say this course.title, or I can say this.get title. Right now, question for you guys you want to think about. Is this compilable? According to the example we did earlier, it shouldn't compile. Okay, let's see why. Okay, I'll explain right away. You want to think, oh, first of all, we know that we are doing this method here in the context of the student class. And then the context object for the title is up to here. This is of type course. Agree? Because courses is going to give you course. That one there is going to give you course. And now if you compare these two, course and students, do they match? They don't match. So that's why you cannot access some private attributes title in the course. No, it doesn't compile. This is some application of the principle that we just said earlier. Okay. So when you study this example here, make sure you also understand the example earlier. Okay. Yeah, so for this method here, it will work if you say this guy over here. But it wouldn't work if you say this. All right? Okay, one more. This one here is also interesting. Right? This one is a bit more complicated. Let's say, for example, if I write, I'll just start here. Okay. Example would be if I say student S dot get name I. The previous case simply will return the title of the course. But now if I say get I, let's say rather than I, let's say 0, let's say 1. What does that mean? That means go to the course of the student stored at index 1 and get its instructor name. For example, here, student S is here. Go to the courses stored at index 1, which is over here. And now I don't want a title anymore. I want you to go further to the instructor and then get their name. In this case, you should return Jonathan. All right? Let's see how we can implement this. Anyone would like to try? This one definitely is trickier than the other two, but I wonder if anyone would like to try. If no, I will just do it. What should I return? But at least from the example, you know what the problem is, right? At least. How about I start you with? I definitely want to get to the courses array and go to index 1. I definitely want to go there first. From there, I need to go further. It's going to be this dot courses for the students at index I. So now I will be in the context of the course. Now, how do I get the name of the prof? How do I get a prof first? Get prof, right? Okay, I'm just answering myself. Get prof. And then afterwards, I can say, for faculty, they have a name here. I can say get name. This will be correct answer. However, what I want you guys to think about as exercise, would it be okay if I replace this one here by prof? Would it be okay if I replace this one here by name? I'll put a question mark over here. You have two ways to verify this. Number one, just try to apply the principle that we talk about. That one rely on your understanding, of course. You can give it a try first, and then you can verify 100% your answer by putting this into Eclipse, and let Eclipse tells you. All right? I would suggest these are very important exercises to really do. Once you have done them, I think they'll help you a lot in figuring out this kind of scenario. Right? We're not just talking about good intention. The intention got to be compilable. All right, question? All right. Question, yes. Which one? Which one do you not get? Okay. Mm-hmm. Okay, sure. Yeah, let's say for this one specifically, not a problem. If you try to get prof, this is not going to be an issue because get prof is going to be a public method. Whenever you talk about anything public, you don't have the issue. However, if I say prof over here, let's write it down. Okay. If you have confusion, I'll clarify it. Let's say we got this dot cs I dot prof. Let's say only up to here. Okay. We know that this cs, we are not in students. Student.cs is going to give you course, right? And then course I is going to give you course, right? If you agree. So up to this point over here, we know the type is course. And now inside the course context, which is another class. Remember, we are now in the context of students, but somehow we navigate to the course by using CSI. Now, this is course. Course.prof itself makes sense. However, does the course match the current context students? It doesn't match. So that's why this will not compile. Okay? Student here, and the course over here, they do not match. Question?
So I have two questions. So where scope is we're focusing on the first one, the student. For the first box, we're able to either ask for the private since they the context object and the private are the same class, but then you can also technically get the accessor. You can use the accessor.
That's correct. So that no, actually, you know what? That's something we really didn't go into. I think having the public accessor in this case, you can see the benefits. Because if you only use private attribute, you cannot get access to it. But if you get public accessor, you can get away from that. That's one advantage of using public accessor. Hmm? That's true. If you always use the public accessor, you're guaranteed running into no compilation error of this kind. But sometimes, let's say if you don't really have the public accessor because you don't want it, there might be a scenario where if the context path has the type that matches the current context class, then you'll be okay. So that's why I will teach you the principle so you can be precise about when to work, when not to work.
And quickly for the second box, so it makes sense why this dot CS, and then you take the index title, that makes sense, but why do you do this dot get? Is that the same thing? Like
The same thing. Because rather than getting access to the private attribute directly, I can also choose to call the public accessor, even though usually in the same class you don't really have to, but it's also legitimate.
It just makes it more like you don't have to think too much.
Yeah, you can think that way. If you never want to run into a situation like this by having compilation error because you're going outside the current context class to access a private attribute, you can always use public accessor. Yes. But I would say you want to be careful because when I ask you a question in the test or exam, I might mix them. In that way, you really have to know where you are. And in reality, you cannot expect other programmers to always stick to always public accessor. They might because they know what they're doing. They only get to the public when they have to, but they use private when they wouldn't get into compilation error. So it really depends. Yes?
Question, sorry. Could you also overcome this compilation issue if you did typecasting to match the...
Okay, interesting question. The question was, are we able to fix the compilation error by using typecasting? The answer is no. This problem here doesn't really have anything to do with typecasting. I'll rather not dive into deeper details, but once we get to the real typecasting discussion, when we talk about inheritance, you will see very obviously. But it has nothing to do with typecasting in this case. Question 2.
No, that was it.
That was it? Okay, just one question. Sure, why not? All right, guys, any follow-up? Okay, think about it. It's an interesting problem to think about. Why don't we do just one more? Okay, so I would suggest others will be exercise for you, but don't worry, all the answers are on the slides. Why don't we just do one more? Okay, let's say we do this. How about this one here? Okay, this one, let me give you the context. Let's say we are now trying to declare this method here, getTitle. And this is in the context of the course class. Okay? In the course class, for example, we might be now in 3311, let's say. And what does it really mean? Let's say, let me write it down here. When I say, let's say 3311, let's say that's the course I want. If I say EECS2030E dot get title I. All right, this one goes as follows. I want to, first of all, find out the instructor for this course, and then go to their teaching assignments. Find out the course that's stored in teaching assignment index I, and then get that course's title. What does that apply to this example? I got EECS3311, go to its instructor, in this case, Jonathan, and then go to their teaching assignment, for example, over here. And then I want to go to their teaching assignment, and then I can give us an index I. Why don't I say 0? Okay. And let me do it again. So EECS3311, go to the course, and go to the professor, go to their teaching assignments, and then go to index 0, which will link you back to some course, which could be this one, in theory. Right? Once you go to the course, and now find out the course title. That's the problem. Okay, now what should we write? Apparently, you want to go from course, first of all, into faculty. And go from faculty back to the course, and then from that course, you want to get the title. That's basically what you got to do. That'll be the final exercise we'll do. But anybody would like to try. Not that long. Why don't you try?
We do course.prof.
Okay, so we're going to say this dot prof.
Yeah. Get to.
Mm-hmm.
And then at that index.
And index I, yeah. That will give you the course.
No. And then you can just do dot title.
Dot title, okay. You're really thinking, because now I can say title rather than get title because now I'm in the course. That's pretty good. All right, that sounds convincing to me. All right, that would be one possible solution. So think about it, and then you really got to practice, right? So the spirits of doing this kind of an exercise is here, is as follows. You want to really follow the navigation link. Let me do it once more, and then we're done for this example here. So when I'm this here, I'm really talking about a course. When I got prof, I'm basically switching to the faculty class. And then when I go to get TE, I'm basically go to this TE, which is course here. And when I go to index I, I'm basically go back to the context of course again. We're navigating between classes, basically. And then after that, I get title, which would be title. Okay. That would be something you would like to get to once you have understood. All right, if no more questions, why don't we take a very short break by taking attendance? Okay, so we got about 10 minutes left. I would suggest I talk a little bit about composition. It's not that really much left. We definitely will start with inheritance. So before I start the composition, I would like to point out one thing. Okay. All right, so for next week, Tuesday, we'll definitely start with the inheritance. But before that, I will highly recommend one exercise for you, which I sent it out last night. Okay? So this is going to be a modeling exercise for you. This is what I would suggest, assuming that you have not seen inheritance before. Okay? Given what we have learned in the course so far, given this problem over here, it's a reasonably complicated problem. It can be like a programming task, right? So now, this problem here, student management system, we got students, we got registered courses, we got different kinds of students there, and we got different methods to really support. So now a question for you. How many classes do you need to implement this? Number two, how can you be sure when you calculate, for example, tuition, depending on what type of student you're talking about, you're going to apply different tuition rate. That would be the critical method to really get right. Now, I don't want you to study ahead anything about inheritance. That's not the point. Without inheritance, how would you do it? I can most likely guess the structure of your code most likely will be the same for if you try to come up with the answer without the inheritance. That will be something I would like to go over with you before we ever talk about inheritance. You will only understand inheritance thoroughly when you compare to see without and with. And really appreciate something we'll see later called dynamic binding and polymorphism. Something later. But this exercise here, I highly recommend you do. It wouldn't take you much time, maximum 1 hour. When you cannot get into sleep in the evening, maybe. That will help you sleep. All right, give it a try. And then I promise we'll start inheritance on Tuesday, for sure. All right, so now, 9 minutes. Let me say a little bit about composition very quickly, see how much we can do. Okay, let me switch. Okay, composition, you want to remember the essence will be no sharing, no sharing. That's something we want to forbid. What classes do we have to consider? Let's consider 2 classes. So we have a class called file. Each file has a name, for sure, and also we have a constructor here, which is going to take a name and then assign the name. Easy. And we got a class called directory, which is a name, also an array of file, and also a number of file. Similar programming pattern. And then we got some directory constructor, which will take a name. Good. Initialize the size array 100. And then add a file. So far, so good. Nothing new. And let's now get some idea about how this will work before we talk about composition. So this will be one test case to illustrate how things can be done with a single directory. With a single directory, we don't have any possibility of sharing just yet. Okay, but we'll get there. So here we got directory. Okay, let's trace line by line. So line number 1, we got D1. Creating D1, and then with name D. You can see directory object over here, and then we have the name D, and then we have D1.files will be an array of length 100 all the way to 99. And then we are simply trying to add 3 files. f1.txt, f2.txt, f3.txt. We're going to create 1, 2, 3 files in sequence. When we try to add the first one there, we're going to let index 0 store this file, and then increment the NOF from 0 to 1. When we try to do the second one here, let index 1 store this file, and then increment from 1 to 2. And we get to index 2, when we get to the third one here, let index 2 store this file. And then we're going to increment from 2 to 3. Right? Pretty easy. At the moment, there's no sharing because if you look at individual file object here, there's only one incoming arrow. Only one, not more than one. Right? So we're good. So modifying, for example, this one here from F1 to F4 doesn't impact anything else. So no violation of the composition just yet. Are we good? Okay. Let's now at least talk about one thing before the end of today. We've got 6 minutes. Okay? I want to talk about something called shallow copy. And before that, let's clarify one terminology from your slide called copy constructor. All right, let's now move on. And this is something we covered before the break. Please do the exercise and reach out to me if you got any concern. And what I want to do is here. All right, so this will be the starting point. So one thing that we want to introduce is called copy constructor. It's nothing complicated. And this will be how you can identify if a constructor is a copy constructor. Here's a rule. So let's say you have a class called X. Public class X. And we know pretty well the rule is the name of the constructor must match the name of the class. So when I want to define a constructor, I'll say public and then X. Now, for the parameter, this is where you can identify whether a constructor is a copy constructor. If the parameter type is just the same as the class we are talking about. For example, I might say X over here, and then other, for example. Right? You can do some stuff here. And you can see the X over here matches the X for the context class. You will know that this is a copy constructor. Intuitively, what we're doing is this X over here is a constructor. That means we're going to create an X objects based on another X objects. Another X object, of course, is indicated by the fact that other is of type X. Right? That's copy constructor. Typically, just one parameter. If you want to expand with more parameter, it's not as typical, but that's fine. Okay, once we talk about copy constructor, we got to talk about the inside or the contents of the copy constructor. Right? Let's talk a little bit more before we let you go. Now, for the copy constructor, the first thing I want to talk about is called shallow copy. Okay? And let me only walk you through the implementation here, and then I'll do the tracing for shallow copy and a deep copy very quickly on Tuesday. And then we move on to inheritance. So for number one, you can see that the directory here matches the directory over here. So we know that it is a copy constructor. Number one. Number two, the reason that we're calling this a copy constructor is we are not trying to make any objects. We're not creating many new objects. Instead, we're only copying addresses of the objects. For example, you can see that. So this NOF is just integer. We're just copying integer over. And this is more like a string. I'll talk about string maybe slightly later, maybe on Tuesday. But for now, let's forget about string. Focus on this line here. What does that mean? Okay. Let's now try to chase this one. And then that'll be it. 3 minutes. So here I'm having some D1. And D1 is exactly as we talked about in the previous page, right? You got 1, 2, 3 files. And then when we get to this line here about calling the copy constructor over here, this is important. You can see here we are calling the constructor for directory, and the argument itself is D1, which is the same, like a directory, right? It's calling the copy constructor. How does it work? So D2 itself is actually going to point to, let me use a different color. So D2 itself is actually going to point to this new directory objects. And then we're going to dive deeper into how this copy constructor can be executed. And here you can see that NOF is going to be D2.NOF, which is something we're going to copy over from D1, which is other. So this is D1.NOF, D1.name, and also D1.files. Right? That's the normal replacement we do when we do tracing. Let's do one by one. When I say D2.NOF is equal to D1.NOF, D1.NOF is 3, so copy 3 over. That one's easy. What about D2.name will be D1.name. You basically say D2.name, oh, copy to the wrong place. I beg your pardon. There we go. 3 should be here. Okay? The name should be also pointing to the same string. However, I'm going to explain a bit further on Tuesday. Having the same reference to the same string is not really violating because string class in Java is called immutable. But I'll get there a little bit more on Tuesday. One more. When I get to the final line over here, when I say files, D2.files will be assigned to D1.files. So D2.files is this reference over here. Rather than creating a brand new array, what I do is D1.files is referring to this objects. I'm just going to let it point there as well. So this will be a shallow copy. Shallow copy means I'm being lazy. I'm not really trying to create new objects for files. Okay? I would suggest try to review this up to here and then before Tuesday. And then we'll start from here and do the tracing and then we'll move on to inheritance. All right? I'll see you next week.